Greetings, Dennis Daniels here. Let's talk about the difference of two squares.
Difference of two squares. Let's do a little more practice with that. And let's try n squared minus 100. Oops. N squared minus 100. It gets factored as n and n, of course, 10 and 10, of course, and because it's negative, plus and minus. Difference of two squares. Let's try one that's might look a little more difficult, but it's not. 1 minus, let's say, 9x squared. Factor that. You're going to put the 1 and the 1 at the beginning, and you know it's going to be a 3, and you know it's going to be an x, because it's a square, perfect square. So all we have to do is add the plus and the minus. That's factoring for difference of two squares. Let's do one more. Let's try this one. Let's say z to the second power x minus 1. Again, that's perfect square. So we're going to have z x here and z x here. And there's our perfect square is 1, so that's a positive, that's negative. Alright, go ahead and try these out on your own. There's lots of examples on the internet.
Alright, difference of two squares. This one, zx minus 1 times zx plus 1 produces a very interesting graph. So let's very interesting plot. So let's take a look at that right now. There is the plot. Oh, I use z. Let's try z. Okay, z, right, of course, not 2. 2, let me show you, I'm sorry. 2 looks like this, but our is z, not 2. Alright, my mistake. Let's try that and see what it does. Should form parabolas, don't you think? Okay, z2x minus 1, yeah. And there's the alternate form. There's the property. And roots for the variable. But it doesn't plot. At least for Wolfram alpha it doesn't plot. Which does make sense because the value of z is unknown. That's a variable, and it would be impossible for Wolfram alpha to understand what in fact is being plotted without a value for z. So if we put an equal sign in front, it should give us a plot, don't you think? And it does. All it wanted was an answer. So there's the plot. Alright, thanks for watching, and happy computing.